Greetings, my fellow humanoid dwellers. I create videos on technology and other random things. If you like this video, you might like others. If you don't like this video, you still might like others. Consider subscribing to my channel or checking out my Patreon page. If you already subscribe, hit that bell. In this video, we're going to talk about a different type of resistor, a potentiometer. To start, I've set up a simple circuit. We're going to go back to resistors to try and describe how a potentiometer works. In this circuit, we have the power supply. The positive side is going to go up to this rail. It's going to go down into this switch. This is a push button switch, so when I push it, the voltage will pass through here. It follows along this line, goes down through this resistor, across this line, up across this resistor, down to this rail, and back to negative. I have meters set up to measure the resistance on each side. So when I start the simulation, you'll see that I have a 1K ohm resistor and a 2K ohm resistor. If you had a circuit where you wanted to have different resistances on each side of this, you could stop the simulation, take the 2K out, put a 4K in, and start the circuit again. That's one way to do it. By adjusting the different resistances on each side of that, we can get different voltage drops across each one. The interesting part about measuring resistance, you cannot do it while voltage is applied. Currently, this switch is stopping the voltage from passing through. If I hit the switch, which will cause current to pass through, the meters go to error. You cannot measure resistance on a live circuit. If you look at the voltage on the meters when I push it, it drops down to 2 volts and skyrockets up to 5 amps. The reason it stops at 5 amps is I have it limited at 5 amps. Now if you remember the way we calculate the resistance of this circuit, we would just add them together. So this would be a 5K ohm total resistance, 4K plus 1K. If I pull the resistors out of the circuit and replace it with this potentiometer, essentially what I've done is the connection between this middle lead and this side was the resistor that was over here, and the middle lead and this side would be the resistor that's over here. So if I want to measure the resistance, I have to move this measurement over to here. I have to put this one between the middle and the other pin, and I need to remove this wire because it will short these 2 pins out. And we're going to connect the ground up to this middle wire right here. The way a potentiometer works, this middle pin is connected to this, what they call a wiper. And then this is a big resistor that goes around here. In this case, I've made it 5K or 5,000 ohms. So if you measure from terminal 3 across to terminal 1, you'll get 5,000 ohms. No matter where this wiper is set, you'll get 5,000 ohms. As we adjust the wiper, you'll notice that the resistance changes between terminal 1 and terminal 2, and terminal 2 and terminal 3. And you can see that's what we're measuring across. So we'll go ahead and start the simulation. You can see the wipers all the way over here, and we get 0 ohms and 5,000. The addition of these two will always be 5,000 ohms or 5K. I'm going to set this about in the middle, and we get 2.4 and 2.6. What a potentiometer does is it allows us to adjust the resistance in a circuit. Now, if we go ahead and apply the voltage to the circuit, because remember the switch doesn't allow it, this should go to error. Since the circuit feeds down through here, through this pin, through the wiper, and out here to ground, the voltage never goes on this side of the wiper. So it continues to measure the resistance. Okay, now we're going to do an example using an LED. We're going to bring the LED over. We're going to change this to read voltage. If we don't change that to read voltage, the circuit won't work. Remember, you cannot measure resistance with voltage applied. We got to connect the terminal number 2, or the wiper, to the other side of the LED. And now what we're going to do is, in this circuit, it's going to flow into here. We're going to go ahead and take the switch out of the circuit by going right down to here. So now the plus connects up to here, goes down to here, goes up through the wiper, back down, over, through the LED, and down to ground. So now when we start it, the light should come on. The exclamation point means it's drawing a little bit too much current and it may pop the LED. But since this is a simulation, we don't really care. As I adjust the wiper closer to this terminal, the resistance goes down. As the resistance goes down, the current goes up. So if I keep adjusting this down, eventually the LED will burst. But since this is a simulator, it'll magically recover. Now if I start going the other way, LED should get dimmer. And as you can see, it is a little dimmer. What we're going to go ahead and do is we're going to go ahead and measure the current next. So I'm going to stop it. You remember the way we measure current is we measure it in series. So we're going to go ahead and leave this one measuring the voltage across these terminal 3 and terminal 2. We're going to take terminal 2 out, run it through this meter down. We're going to take this wire and move it over to here. We have to adjust this to measure current. Now we can go ahead and start the simulation. What we're drawing is 5.61 milliamps. This LED is rated at 20 milliamps. So we should get the exclamation point as it approaches 20 milliamps. There, right there, we got the exclamation point. Right there it went out. The interesting thing you'll note is the voltage stays the same. We haven't discussed what an LED is yet, but LEDs try to hold the same voltage across these two pins no matter what the current is. And you can see that it's working just like it's supposed to. That completes this video. Thanks for watching.